So طبعا بعد ما تكلمنا عن محاضرة اللي هو trans amines وأهميتها في اللي هو تصنيع some of amino acids like when we transaminase الألينين عشان نعمل glutamate أو transaminase الglutamate عشان نعمل ألينين أو transaminase الأسبرتيت عشان نسوي glutamate. فهذه البروسيس راح ينتج عنها زي ما قلنا keto acids like اللي هو alpha ketoglutarate which is precursors for TCA cycle, and من الأنينين راح يطلع البيروفيت which is also a precursors for TCA cycle, as well اللي هو الأسبرتيت راح يطلع لنا الأوكزالو أسيتيت which is as well TCA precursors. Okay. طبعا زي ما تعودنا دائما نتكلم احنا في الميتابوليزم عن حالتين، اما عن حالة اللي هو الويل فيد اوكي، او الحالة الاخرى اللي هو حالة fasting starvation or exercise, right? Okay. So لو احنا مثلا we are well fed and we ate big meal مثلا فيها بروتين اوكي rich in protein، صار عندنا absorption للامينو acids راحت للبلد and then it get distributed all over the cells اوكي. طبعا كل خلايا الجسم اخذت فائدتها وكفايتها من الامينو acids، والان صار عندها امينو acids x axis اوكي. So عندنا axis amino acid. ايش بيصير في الاكسس امينو acids هذه؟ طبعا الخلايا ما تقدر تتخلص من الاكسس امينو acids لانها ما عندها اليوريا سايكل، فبالتالي راح تودي الامينو acids الى الليفر اوكي. So مثلا for example عندنا مثلا الانتستين اوكي، عندنا المسل اوكي. I know spelling mistake. طبعا من ال interesting thing that we should know إنه ال intestine أو ال GI tract in general they are mainly يتغذون على الجلوتامين okay amino acids okay. And we know that muscle عندها contractile cells right، عندها non-contractile cells. in here طبعا هي تحتفظ بكمية كبيرة من ال branched chain amino acids. branched chain amino acids هم 3 amino acids اللي هم مين؟ isoleucine, leucine and valine. Okay, so isoleucine, leucine and valine. Okay, so في حالة ال well fed muscles they don't need to break down their own amino acids okay. So طبعا هذه ال branched chain amino acids نعتبرهم اللي هو ال free amino acids اللي موجودة وين؟ موجودة في المصل. في حالة احنا we starve we use them اوكي. فالجسم يحتفظ تقريبا 40% من الستركتشرز حق البادي هو عبارة عن بروتين right أو skeletal muscle. فبعد الفات تعتبر البروتين that coming from muscle هي second storage اللي هو في الحجم كأكبر storage عندنا بعد الفات، بعدها طبعا يجي الجلايكوجين. لكن in theory we don't store amino acids، لكنهم احنا we had a lot of branched chain amino acids in non-contractile muscles موجودة في اللي هو skeletal muscle. اوكي. نرجع مرة ثانية للانتستين. طبعا بعد ما الانتستين أخذت كفايتها من الأمينو أسيدز، فهي إيش بتعمل؟ عندها سبيشال إنزيم اسمه جلوتامينيز. طبعا الإنزيم هذا هو موجود في الانتستين and as well it exists in kidney. طبعا الإنزيم هذا إيش أهميته؟ أهميته إنه من الجلوتامين أوكي can convert glutamine إلى glutamate أوكي and يعطينا free ammonia. لأنه if you remember from the structure of glutamine exactly the same like glutamate. The only difference between glutamine and glutamate that glutamine it has 2 ammonia, while glutamate it has only 1 ammonia. So when we get rid of 1 ammonia here, we have the glutamate, okay? Okay, so we form the glutamate and the free ammonia. So what's going to happen with this free ammonia? The free ammonia, will be transferred to liver in case of intestine. Yeah? Throughout what? The portal vein. Because we know that muscle are connected in intestine are connected in enclosed system with liver. So it will reach into the liver. Why? Because liver can do urea cycle to form urea, yeah? However, intestine, they cannot do. The second organ that we said it can form free ammonia is kidney. In kidney, via glutaminase, okay, we can get rid of free ammonia directly into the urine. Okay. What about other organs? Okay, other organs, how they will transfer their free ammonia to liver, because other organs they cannot do urea cycle. We know that. We know that liver and kidney, they are the 2 organs that they can form urea. Okay. However, in kidney, only it involves 5% in urea formation. Most of the urea we formed come from liver, okay? So liver is the major organ where we do urea formation. That's why all the cells send their excess ammonia to liver. Okay, how they send them? They send them through amino acids. Why? Because ammonia is very toxic and it cannot travel in the blood alone. Otherwise, it will damage the cells. So in order to be safely transferred to the liver, we use amino acids to transfer the ammonia to the liver. all the cells in the body transfer the ammonia via glutamine. Okay? Except muscle, who do transfer their excess ammonia or excess, ammonia via alanine. Okay? So that means the cells, okay, must have special enzyme in both cases. Okay? ففي حالة ال other cells, all the cells in the body, when they use amino acids and they had enough and they don't want any more, so because they don't have urea cycle, they send the excess ammonia to get rid of it into the liver via amino acids. They use glutamine. Most of the cells, they have glutamine synthetase. So this enzyme will form, okay, glutamine, of course, because it's synthetase, from glutamate. And we will transfer the free ammonia in here, okay? For the second case, which is muscle, they will also use alanine to transfer their excess ammonia. So what they're gonna happen here, they will use an enzyme that we talk about it, which is ALT, to transaminase the glutamate to alanine. And here they will use pyruvate, and in here they will produce alpha ketoglutarate. Okay? Right. So once the cell receive the the hepatocyte, okay, receive the glutamine or alanine, they will convert them, both alanine and glutamine, to glutamate. Okay, so the glutamate has a special enzyme that can get rid of the ammonia, okay, which is glutamate dehydrogenase. We talked about this enzyme in the previous lecture. For this one, we need NAD plus or NADP plus as a precursors, and then we'll produce NADH or NADPH, and the final product will be free ammonia, okay, and alpha ketoglutarate. So what's gonna happen for this free ammonia? That about well-fed state. On the other hand, what's gonna happen if we are fasting, exercising, starving? So how the cells will utilize the amino acids? First thing we need to know that during exercise, 15% of the energy we get, it to 25% it will come from amino acids. Okay, so the second thing, that amino acids can produce 34 ATP, similarly like glycolysis. Okay, so what happened during fasting? Especially طبعا all the amino acids, because we are fasting, we don't have a dietary amino acids, so the amino acids, where it will come from? It will come from mainly from from muscle. Okay, it will come from muscle. من وين بالضبط؟ من ال branched chain amino acids. In muscle, they have a very special enzyme that other cells they don't have. It's a branched chain amino acids, a branched chain amino. Okay, I will write it full. Branched chain amino transferase. Okay, so what these amino acids will do, will aminotransferase the branched chain amino acids, and it will produce alanine and glutamate. Okay, alanine, okay, and glutamate we said, yeah. So what happened? The glutamate will transaminase to alanine, okay, through the ALT, right? And then alanine will be transferred to the liver. This cycle is called alanine. Let me write it using different color. Okay, alanine glucose cycle. So the liver will receive a huge amount of alanine during fasting, starvation, exercise, and what the liver will do, because liver, they can do glyconeogenesis. How does that happen? طبعا once the liver receives the alanine, okay, right, so it will convert it to pyruvate. Okay, through what? ALT again. So we will get pyruvate and glutamate, right? Okay, and the glutamate will be through glutamate dehydrogenase will produce what? Will produce, okay, free ammonia, which will enter urea cycle. Okay, in urea cycle, okay, we have a cycle. We can produce a fumarate, which then can enter TCA cycle and produce an ATP. And from pyruvate, we can also produce glucose, and this glucose will be transferred to muscle and other cells in the body. Okay, so one more thing about regulation. Regulation is a very complicated process in the case of amino acids, and it includes allosteric regulation, hormonal regulation. We'll talk only about glutamate, okay, dehydrogenase, This amino acids is highly regulated by two main things: the glucose level and calories. Yeah, it regulates by fasting states. We need to know that this enzyme, it has a very low affinity. Okay, we need to say low affinity to ammonia. What does that mean? It means that we said that from glutamate, yeah, we actually use NAD plus or NADP plus, okay, to produce NADH, and glutamate dehydrogenase actually can produce free ammonia, yeah, and alpha ketoglutarate. Okay, because it has a very low affinity for ammonia, okay, the enzyme, it has a very low affinity of ammonia. This reaction cannot be reversed, okay, cannot be reversed to form glutamate. So once we commit to form the free ammonia, okay, we will never go back again to glutamate, unless in one case, which is the one case if the concentration of free ammonia in the blood reach up to toxic level. This actually, because it's very high concentrated in the blood, this actually will activate the glutamate synthesis. So instead of forming a free ammonia, we'll start to form glutamate using the excess free ammonia in the blood. Thank you so much, and we will have one more lectures to include urea cycle and other amino acids.